And over here, we have used a logistic regression model. And as you can see, we have fit the model on X train and Y train. And then we have predicted our logistic regression on the X train. And this print statement over here will show the model accuracy. And this will show the model accuracy on train. And this will show the this print statement will show the model accuracy on test. And as you can see over here, our model accuracy on train is 91 and the model accuracy on test is 65. Apart from logistic regression, we can also use other machine learning models like the decision tree classifier, and we can also use the random forest classifier. We can also use the support vector machines, and in the end, we can compare all these models with their evaluation metric, which is the accuracy, and come to a conclusion which model performs well. And over here, as you can see, the logistic regression has given us an accuracy that is 65%. And let us go ahead and compare the other machine learning models accuracy. And over here, you can see these are my imports. And in the imports, I have imported the decision tree classifier. And then we have the random forest classifier. We also use the k-nearest classifier over here. This is the KNN model. It is called as k-nearest neighbors. And this is the support vector machine. And when it comes to decision tree classifier, what a decision tree classifier does is that it breaks down a data set into smaller and smaller subsets. And decision trees are known to be good for both classification and regression problems. And when it comes to a random forest classifier, random forest classifier is a machine learning algorithm which can again do the same task as decision tree. It can work very well for regression and classification use cases. And random forest classifier is actually called as an ensemble method. And random forest model is actually made up of large number of small decision trees. So it's a collection of small decision trees. And then we have the k-nearest classifier, and this is called as the k-nearest neighbors. And then we have used the support vector machine. Support vector machine is called as a supervised machine learning algorithm. Again, this model can be used for both classification and regression problems. And all these models are going to get evaluated with the help of metrics. And the metrics that we are going to use over here is the accuracy score and the confusion matrix. And what a confusion matrix really does is that it will tell us how many predictions were classified correctly and how many predictions were classified incorrectly. So it is good for classification problems. And over here, as you can see, this is my decision tree classifier. And what we have done here is that we have fitted the model, and we have over here this line of code. It says that we have predicted the decision tree on the X train, and we have printed over here we printed the model accuracy on X train, and over here we have predicted the decision tree on X test, and then we have predicted the models on the X test as well, and we have printed it over here using the print command. And over here you can see we have given this code. What it really does is that it will draw a line, a dotted line, which will repeat for 50 times. And then over here we used a confusion matrix, and this confusion matrix will tell us how well our model is classifying. And over here we have made the calculation of this confusion matrix, so it will predict how many predictions were wrongly made. And then we also use the kappa score over here. And as you can see over here, our model accuracy on train is 100%, and the same thing is on the test as well. So what this really shows us is that our model is overfitting, and this has to be tackled. And as you can see over here, the wrong predictions out of total are 0. This is a overfitting model. So let us go ahead with another model, which is our random forest classifier. And as you can see, same thing has been repeated over here, but the model that we used here is the random forest classifier. We have fitted the model on X train and Y train, and then we have predicted on the X-train, and here comes a print command, and the same thing has been done on the X-test. We have used the random forest model to predict on the X-test and print the same thing over here. We are predicting the accuracy on X-test, and again this line of code will draw 50 dotted lines, and over here we are using our confusion matrix, and the confusion matrix, so the calculations of the confusion matrix are done from this code. And as you can see over here, the model accuracy on train is 100 and our model accuracy on test is 60. And over here we have used the confusion matrix, and this is the total number of wrong predictions made by the random forest classifier. And as you can see over here, the total number of wrong predictions made are 80 by 200. So this is not a very bad model. It can be further improved. And then we have used the k nearest neighbors. So, but so far, we have a good model over here. The random forest classifier has performed very well compared to the other models. And the logistic regression also has given us a 65% accuracy. And over here, we come to a conclusion with the k nearest neighbors. So we have used the k nearest neighbors and fitted the model on X train and Y train. And then we have predicted on the X train, and this is our model accuracy. We have printed the X train prediction, and over here we have fitted we have the predict on the X test, and this is the model accuracy on test. And then again we have the 50 dotted line, and over here we have printed a confusion matrix, and these are the total calculations made by the confusion matrix. Over here we have done the calculation part, and as you can see over here, the model has given us an accuracy of 71% on train, and the model's accuracy on test is 55. And this is our confusion matrix over here, and the total wrong predictions made out of total are 90 by 200. So so far our random forest classifier and logistic regression have performed very well compared to other models. The other thing that can be tried here is that we have used a TF-IDF vectorizer. The same can be done using the conv vectorizer, and we can apply the same machine learning models on the conv vectorizer to see if there is any increase in accuracy on these models. And apart from all these models, I've also used another model called as support vector machine, and let us see how the support vector machine works. And as you can see over here, this is our support vector machine, and I used a kernel which is linear, and then I fitted the model using svm.fit on X train and Y train. And over here we are predicting on X train, and this line over here will predict the model accuracy on train. Over here we have predicted the support vector machine on X test, and again this will print the model accuracy on X test. And then this is the confusion matrix which will be used for evaluation, and again this is our total number of wrong predictions made. We are calculating this from the confusion matrix, and as you can see over here, this model also has performed very well. The model accuracy on train over here is 94, and the model accuracy on test is 69. And over here you can see this is our confusion matrix, and these are the total number of wrong predictions made. And over here we have 61 wrong predictions out of 200, which shows that support vector machines has worked very well, and the decision tree classifier has overfit. And in the end we can conclude that support vector machine is the better model for our sentiment analysis use case. This model can be further improved, and the accuracy can also be improved. We can try using the conv vectorizer as I told earlier. But for now, this is it for this video. We can also use XGBoost classifier to see if there is any improvement in our model. We can also use conv vectorizer and run all the models again to see how well the model performs and check if there is any difference in the performance of these machine learning models. And We can also use other machine learning models and compare every model to see how these models work. But so far, the support vector machines has given us a good accuracy with the total number of wrong predictions as 61. And that's it for this video. And thank you for watching this video. Have a good day and take care.